Okay, friends. So in part number one, we have seen about the basic introduction or familiarization MATLAB software. The second one is about a single exercise, and the third one is which extension from part number three. I mean part number two. So in part number two, we have seen that drawing representing two different functions in a single graph by using this MATLAB software. So the first graph is in the x function. The x function is already a common the common point, and here the y is separately presented in the first exercise and the second exercise. For my first y function is sin x, and for my second graph my y2 is a cosine function. So now for the first single line, the graph looks like this, which is a sinusoidal wave starting from y value at 0 and which is tilted in an upward parabola here from 0 up to 1. So there is the downward parabola after a certain decay, and it's coming to here, and which is started to growing the graph starting from in between 4 and 5, which is almost near to 4.8, from 4.8 to the last, which is the graph is gradually increasing and increasing up. Here the gradually the graph starting from 0 to increase and which reaches in the peak value, and then decrease down, and here after here it starts, which is a sinusoidal wave like structure. The second graph is the same, and which is a cosine function. Sinusoidal wave is in a sine function, and the cosine graphs are always in an upward parabola. Here starting from 1, it's decreasing down to here, and again tilts to up here. So the graph is presented in such a way. So now my friend is writing an algorithm to represent these two graphs in a single and separately. The first is in a solid line, and let's put the first graph in a solid line and the second graph in a dashed line. So a dashed line means giving the line. So that's an algorithm. So from here, let's enter and just plot. Let's say plot here x comma y, which means the first graph and the first function then separately here. Sorry. So here. So my first graph is in hidden line. So hidden line is represented by two lines here, one here, and the second function is by separating comma, and here I have x comma, again I have y2, because here y2 is already known, again comma, here I have here now I have here, which is a single line here. So for this particular algorithm, we have to see about the first graph here. Here is the first graph, see, which is a sinusoidal wave. The sinusoidal wave is now representing in a dashed line. So it is a solid line, not dashed line. So now, in order to separate the two graphs in a very different manner, look, I have given the algorithm x comma y. The first graph is in a dashed line, and the second graph is as a solid line. So here I have run at all. After taking a very single second, the value, the graph value, or the graph function will be appeared in such a way here. So as I mentioned earlier, here this algorithm symbol makes the graph in a dashed line. Look, there is a dashed line here. So here again, another thing you have to know is the graph is presented in such a manner. And let's say about bringing the legend, the first graph and the second graph here in live determine here a color bar. After clicking in the color bar is starting from 0 up to 1. So the value is starting from here 0 up to 1 here. So there is a 0 and 1, the y value here. So there is a color bar again in a legend, which is basically important. The pressed data. This graph is the pressed data one is the yellow color. Data one is a sinusoidal wave, and the data two is it's a cosine graph. So here is the same again. Let me bring about the color bar here. So which is parallelly representing the graph in a very detailed way. So let's say uh, uh, let let's say look. So it is starting from 0 up to 1 again, and let me bring the legend in here. In the above legend, here we have let's say called is a dash, which is a solid line. The yellow color is I mean this yeah, the blue color is in a solid line. So in here, let me show you the blue color is in a dashed line. So let me bring up the legend in here. Yeah, look. So the data one, my data one is, let's say my data one is in a dashed line, which is a sinusoidal graph, and my data two is in a cosine graph. So this is all about how we can represent the two different functions in a single graph. So there is the bar representation, and there is the legend. So this indicates about the data. So in here, if I bring the color bar in here, which is the yellow, which is starting from 0 up to 1, and my data is now is 1. So I have only here single yellow sinusoidal waves in here. So that is especially my today's exercise to all of my students in all over the world. Especially, this is help. This may help you in numerical analysis for engineering courses in mathematics. So in mathematics, after applied 1, applied 2, and applied 3, for every electrical and electronics engineering students, and the most electromechanical engineering department, mechanical engineering department, here I have in mathematics, we have taken a course after applied 1, applied 2, applied 3. After 3 calculus courses, we are engaged in numerical analysis for engineers. So numerical analysis for engineers are especially linked with this MATLAB calculation. So it's a mandatory, by the way, because it is a very introductory class. It's not detailed algorithm. So in future, we have to see about the versatile definition algorithm of mathematics in this MATLAB software, especially engineering, electrical engineering, and electromechanical engineering department. So in electrical engineering, especially the control stream have the highly linkage in this MATLAB calculation. So every value we got in now mathematics, especially calculating 4 by 4 matrix in a manual way, is it's a very tedious and it's boring. So in order to eradicate such a boring way of studying in a classroom, or doing an assignment, or doing a project, or like doing a thesis work in a manual calculation, is very boring. So in order to solve that way, we have to know about the MATLAB benefits and the versatile advantage in engineering analysis. That's why I started in the MATLAB software training course in online to all of you. So there is, as I mentioned earlier, the introductory class. We will see about how we can represent the MATLAB graph function is in a single way, in a double way, as well as in a triple way. So here I have an x and y axis here. So this is what we call it, it's a coordinate axis, in the x coordinate axis and the y coordinate axis. So now we'll see about the three-dimensional axis. We have x, y, and z axis. So after all, we'll see about that again. So there is the first class, and let me show you about one single exercise after here. So before that, let me introduce you about this